Hi there, I'm Hao, and it is just another video of me solving randomly code problem. So let's begin. Given a string containing the digits from 2 to 9 inclusive, return a possible letter combination that the number could represent, and return the answer in any order. So we have the mapping from the digit to the letter below, right? 1 doesn't count, 0 doesn't count. We only have 2 to 9 here. Right, 2 have 3 letters, but 7 have 4 letters, 9 have 4 letters, so on and so forth. Right. So let's say we have uh, 9, 7, right? 9, 7. So we can start out at an empty string, right? We have 4 options because we start at 9. So we're gonna have W, X, Y, and Z, right? And next we can look at the 7. 7 we have P, Q, R, and S, right? P, Q, R, and S. So we're gonna have P, W, Q, W, R, W, S. Right? Similarly, we're gonna have XP, XQ, XR, and XS, right? Same for Y, YP, YQ, YR, and then YS. For Z, we have ZP, Z, ZP, ZQ, right? ZR, and then ZS. Okay. So what is our time complexity here? So we have like the maximum path you're gonna have is 4 paths, right? Because the maximum number of letters we have in one digit is 9 or 7, which is 4. So we have 4 possible paths. So to um n is our recursive depth. So how many times have we how many times do we have to call the function recursively? So each time, right, we're gonna add a letter in the digit, right? Until we reach the length of the digits, right? So we can say to the n, right? Where n is the length of the digit, right? So let's say we have 9, 7, right? We can do WP, which is the length of 2, right? That is equal to the length of the input here, which is 9, 7, right? So n is the length of the input digit string. So this is the recursion depth, right? Here. And how many times that we have to do the backtracking? We need to do it n time, right? Why? Because we have n letters, right? So n here is also referring to the digit length. We need to do it for each digit, right? For each digit, we need to run the backtracking. So that is 4 to the n. Okay, so yeah, that's pretty much it. So our general strategy is that we can just iterate through each digit, right? Like 2 or 9, right? And when I look at the letters that 9 have and run the backtracking for each of them. So what is our base case? Our base case is when we reach the length of the digits, right? If when our recursion depth with the length of the digits. So in other words, our string here, right, is equal to the length of the input string. Then we're gonna add it to our combination array. Right. So let code this up. So we will have a combination arrays. We can return at the end combination. We also need our mapping, right? So we can call it digits to letters, right? One is ABC, two is DEF, three. Oh, sorry, it is two. It is 3 is 4, 4 is QH9, 5 is JKL, 6 is MNO, and then 7 is PQRS, 8 is EUV, and lastly, 9 is WXYZ. Okay, so we need our Babel function for backtrack. We can check in the index, the index of the digits, right? The current index of the input digit that we are looking at in the current string, right? We can call the backtracking function here. Can start index 0 and an empty string. Right? So we only want to call the backtrack function if the digit length is greater than 0, right? Okay. So if the string of length is equal to the digit length, which means we reach our base case, we want to push in our string, right? We got one combination. Otherwise, we want to look at the current digit, right? Which is digits at index. We're gonna look at the letters equal to the map, right, of the digit, and we can map to the letters. Letter for each letter in order for the backtrack function. Moving on to the next digit, so index plus 1, and we need to add the letter to our as we iterate that, right? Our recursion depth. So string plus letter, and that's pretty much it. Let's give it a try. Letters are for each is not a function. Yeah, of course, because letter is a string and for each is only for array. So I can just do a regular for loop here. Okay, let's try it again. Undefined. Oh yes, we need to return. We need to push it in and then return because we reached our base case here. So we need to return. I forgot that. Okay. And it is accepted. Our display complexity would be of n, right? Because we need to store all of the digits and the letters. And thank you for watching.